Okay, today we are going to talk about parametric equations and rectangular equations and how we change back and forth between the two of those. And so the first thing we're going to do is we're going to find the rectangular equation given the parametric equations. This can also be called eliminating the parameter. Okay, the steps that we are going to use, we're going to solve one of the equations for t. So you get the x equation or the y equation, you're going to solve it for t. You're going to take that and substitute it into the other equation, and then you're going to simplify. So it's very much like substitution that you maybe learned in an earlier math class. Okay, for our first example, we have the parametric equations x equals t squared minus 4 and y equals 1/2 t. So these would create a graph the way that we did in the previous lesson if we were to plot it. But what we want is to turn it into an equation that has only x's and y's, no t's. So we pick one to solve for t. And to me, the bottom one is the easiest. So I'm going to multiply both sides by 2. I'm going to get 2y equals t. And then I am going to plug that 2y in for the t in the other equation. So I'm going to have x equals 2y squared minus 4. And so now if you'll notice, this equation has x's and y's in it, but it does not have any t's. And I can simplify that a little bit and get 4y squared minus 4, which, as we have been learning, would be a parabola that faces right. Just to have that knowledge there. You could solve it for y if you needed to. Now you could work with this in several other ways, but the main deal is to solve one equation for t and plug into the other equation and then get it just in terms of x's and y's. Okay, for our second example, we are going to look at one that's a little bit more complicated. Again, I start with parametric equations that have x and t and y and t, and I'm going to try to get it down to one equation that has just x's and y's. So I pick whichever one I think is easiest to solve for t, and in that case it would be this bottom one. I'm going to start by multiplying both sides by t plus 1 to get rid of the denominator. And so I'll cancel that there. And I have y times t plus 1 equals 1. And again, I'm trying to solve for t, so I'm going to divide by y. So t plus 1 is going to equal 1 over y. And then I'm going to subtract 1. So t is going to be 1 over y minus 1. Now I'm going to take that and I'm going to plug that into the top equation for t. And we had not messed with that prior to this. We had only messed with that bottom one. So if I come over here, x is going to equal 1 over the square root of, in place of the t, I'm going to put 1 over y minus 1. And if you need to put that in parentheses to understand that that was just t, that would be great. And then you have the plus 1 that's there as part of that. You'll notice you really don't need the parentheses because there's nothing, no power to put in there or deal with or number to multiply in. So you really don't need those parentheses. You can actually look at it and say, oh, I've got a -1 and a +1. I can combine those. So I have 1 over the square root of 1 over y. Well, now I need to look at how to simplify that. The square root, I can look at the top and the bottom separately. So the square root of 1 is 1, and then I have the square root of y. And since this is a fraction, I'm dividing by a fraction, I'm going to write down the top, and then I'm going to flip the bottom and multiply. And I get the square root of y when I do that. So that means that x equals the square root of y. I can write it like this, or I can square both sides and write it as y equals x squared. So either one of these is a good answer because you're down to x's and y's. It just depends on what you need at the moment, what you're trying to accomplish. Okay, now for the next few examples, we're going to be going the other way. We're going to be finding parametric equations from a rectangular equation. So we're going to take an equation that has x's and y's and go to two equations, one that has x and t and one that has y and t. And again, the main thing that we're going to be doing is substituting. Okay, so for this problem, they have given us a rectangular equation, y equals 1 minus x squared, it has y's and x's, and they've given us an a and a b. In one, they've told us let t be x, and in the other, they've said let t be 1 minus x. So we're going to take it one thing at a time. We're going to do part A. Well, if t equals x, and those two things are equal, then one of our equations has to be x equals t. So it's that simple. The other one has to be y equals something involving t. And if you take the y equals equation from the given, and you plug in t for x, you get 1 minus t squared. Now you have two equations, one is x and t, one is y and t, and you're actually done at that point. Part B is a little bit more complicated. You have a little bit more of a step because they're not exactly one-to-one equal here. So if t equals 1 minus x, I can solve that for x. So I'm going to say t equals 1 minus x. I'm going to add the x to the other side and then subtract t. So x, one of my equations, is going to equal 1 minus t. So there's one of my parametric equations. For the other one, I'm going to have to plug into the y equals formula to get some y's in there. And so I'm going to say y equals 1 minus, and then I'm going to plug in for x. And I found that x was 1 minus t. So 1 minus t squared. And I can leave it like this, or I can double distribute and combine like terms. So I think I'll do that just for the practice. You need to do the power before the negative because of the order of operations. So I'm going to write it twice, and then I'm going to FOIL it out. I get 1 minus 2t plus t squared, and then I'm going to take the negative in, and I'm going to finally put things in order and combine like terms. So I have a negative t squared plus 2t, and then 1 minus 1 will be 0. So this is my other equation. It has y's and t's in it. Okay, for our last example, we have changed up the directions a little bit. It says find two different sets of parametric equations for the given rectangular equation. In other words, you've got to come up with the t thing by yourself, the x equals t or whatever by yourself. And as long as you substitute incorrectly, you should get an answer that works. So for the first one, I'm going to take that very simple x equals t that we used in the last example because that's the easiest one to do, because it's already one of your equations. And then I'm going to use that to plug in, and y would equal 4t minus 3 if x and t are equal. And so there's the easiest possible set of parametric equations from a rectangular equation. Then, for the second one, you can make anything up you want. So I'm going to make up x equals t plus 2. And if that's the case, because it's already x equals, that's one of my parametric equations, but I'm going to have to plug it in and get the other. So y is going to equal 4, put in t plus 2, minus 3. Then I can distribute and combine like terms. And there is the matching set of parametric equations here. My x equals something t, my y equals something t. And again, because of these directions, I can make up whatever I wanted, and I went with x equals t plus 2. I could have used something like x equals t minus 1, or x equals t squared plus 5. Whatever that I have, if I could plug it in to my equation to make it work, then I'm good to go.